large language models to self-debug. Self-debugging teaches large language models to perform robot debugging, namely without human feedback and intervention. Large language models can identify code errors by investigating the execution information and explaining the generated code in natural language. Self-debugging uses large language models to improve the generated programs iteratively until the generated program passes all test cases. At each debugging step, large language models first generate a seed program. Then the code is executed and the large language models explain the code. The code explanation, along with the execution results, constitutes the feedback message based on which large language models infer the code correctness and then add the message to the feedback. The feedback message is then sent back to large language models to perform more debugging steps. Here is a self-debugging framework for iterative debugging. One turn of self-debugging consists of 3 steps, namely generation, explanation, and feedback. For generation, given the task description, large language models predict the candidate programs. For explanation, large language models are prompted to explain the prediction in natural language or create an execution trace of the predicted code for a sample input. For feedback, generate a feedback message of the correctness of the predicted code. This can be determined by asking large language models themselves or can be generated externally from unit tests. Self-debugging terminates when the feedback message states that the prediction is correct. The simple feedback is true or false to indicate the correctness of the generated programs. The execution results are incorporated into the feedback to provide the rich information. Self-debugging explains the generation programs. For example, robot debugging, where large language models debug a program line by line to a robot duck. By describing the code implementation and comparing it to the task description, large language models identify the bugs. When unit tests are available, large language models are instructed to explain the intermediate execution steps line by line. Text-to-SQL generation represents the scenario where self-debugging enables large language models to identify errors and justify code correctness by explaining the predicted code. The goal of text-to-SQL tasks is to generate a corresponding SQL query given a question and database information. The task description contains the database schema and the large language models applied to predict the SQL query. This is a large language model prompted to generate a SQL query. The SQL query, explanation, and feedback are all predicted by large language models. Here is a self-debugging prompt for text-to-SQL generation. At a high level, the self-debugging process contains 3 steps. First, the large language models are prompted to summarize the question and infer the return type required by the question. Second, the SQL query is conducted and adds the returned table to the large language model input for code explanation. Finally, large language models compare the inferred SQL explanation and the question description, and then predict the correctness of the current SQL query. For more details, please check with these references. Thank you. Bye.